Hello everyone. In today's lecture, we are going to learn about differentiation of logarithmic functions. Okay. Now, so if we have a function y is equal to logarithm of fx, where ln means it's the logarithm to the base e or ln of fx. So in this case, the rule says dy by dx or y slash is equal to the differentiation of that function or derivation of that function upon that function. So let's take an example to see how this is done. Let's say we have an expression y is equal to ln of 3x cubed plus 5. Okay, so here we have this is the function x. Okay, so if we have to find out the differential of this or y slash, which is the same as dy by dx, so since the function is 3x cubed plus 5, the derivative of that function is 3 is a 9x squared plus 0, and since the function is 3x cubed plus 5, so this is how you get the derivation of logarithmic expressions. Let's take another example. Let's say y is equal to ln square root of x plus 1. So here the function is equal to root of x plus 1 or x plus 1 to the power half. So what is the derivation of that function? Derivation of that function is half of x plus 1 to the power half minus 1 into the derivation of this function. The derivation of this function is derivation of x, that is 1, and derivation of 1 is 0, so it has to be multiplied by 1. So this remains. So the answer is 1 upon 2 square root of x plus 1. Okay, so the derivation of this function becomes f dash x or upon fx, which is f slash x is 1 upon 2 root of x plus 1 multiplied by the function 1 upon the function, that means it's 1 upon the function, that is root of x plus 1. Okay, which is the same as writing root of x plus 1 into root of x plus 1 gives us x plus 1. So this is how you solve problems on derivation of logarithmic expressions. Okay, let's take another example. Let's say y is equal to x upon x plus 1. Now there is no logarithm here. So, and we know that this is a fraction, where this is an algebraic expression and this is an algebraic expression. Okay, and we know that this we can apply the quotient rule of differentiation to get the derivative of this function. So here we can say y dash is equal to, the quotient rule says x plus 1 into the derivation of the numerator, that is 1, minus the numerator into the differential of the denominator, that is again 1, upon the denominator whole square. So we get x plus 1 minus x upon x plus 1 whole square, which is the same as this, and this cancels off. So we get x plus 1 whole square. Okay. What is the second method? Second method, we can apply this rule for logarithms. So if we take the logarithm of both the sides, we'll get ln of y is equal to ln of x upon x plus 1. So this is the second method. This is the second method. Okay. So this is the same as writing, if you apply the law of logarithms, logarithm of a upon b is logarithm of a minus logarithm of b. So it is logarithm of x minus logarithm of x plus 1. Okay. Now we apply the rule for derivation of logarithmic expressions. So we know that the derivation of this gives us the function itself upon the function itself, the derivation of that function upon that function. So it is y slash upon y. Now, what is the logarithm of x? Derivation of this equal to, it is 1 upon x. And what is the derivation of ln of x plus 1 equal to? It is the logarithm of, the derivation of this, that is 1 upon the function itself, that is x plus 1. Okay, so we get y dashed upon y is equal to, if you take the LCM of the expression, so this will be x plus 1 minus x, which is equal to 1 upon x into x plus 1. Okay, now so y dash, which is nothing but what we are looking for here, which is equal to y multiplied by this expression. So it is 1 upon x into x plus 1 multiplied by y, which is the same as x upon x plus 1. What is the value of y? We can substitute the value of y here, which is x upon x plus 1. So we multiply x upon x plus 1 here instead of y. So this x and this x cancels. We get 1 upon x plus 1 square. This is the same answer as we got by applying the quotient rule also. Okay. Okay, let's take another example to make things more clear. So let's say y is equal to x to the power x. Now, in order to solve this, we will apply the logarithm on both the sides. Apply logarithm on both the sides. So we get ln of y is equal to ln x to the power x, which is the same as x ln x. Applying the rule of logarithm for logarithm of anything to the power is the power times the logarithm of that number. Okay, so now we apply differentiating both sides. We get this is y slash upon y, and this is x ln. Now it's a product of two functions, so we'll take the first function into the differential of the second function, which is 1 by x, plus the second function into the differential of the first function, that is differential of x is 1. So we get this as 1 plus ln of x. So y slash is 1 plus ln of x into y, which is 1 plus ln x or ln of x into x to the power x. We substitute y for x to the power x. So we get the differential of that function. Okay. So this is all for today's lecture. In the next lecture, we will be talking about differentiation of exponential functions. Till then, thank you for watching and meet you in the next lecture.